Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope that everyone is doing all right out there. I don't remember the title of this lesson. Could be 18.3 or 18.1 or Unit 5, whatever. Depends on what class you're in. But what I do know are our goals for the day. And we have 3. Our first goal is going to be to investigate dilations. Our second goal is going to be to review rules for rigid motions, which are translations, reflections, and rotations. And our third goal is going to be an introduction to the sequence of transformations, how to use the rules, and does order matter? Okay, so I want to start off with a story that I like to tell when I introduce dilations. All right, and so this is supposed to be me. And I'm on a roller coaster, and this is a laser that was at Space Mountain at Disneyland. And the laser it shot out triangles, right? And I remember going up the roller coaster, I go, oh, look at the dilations, right? And so a dilation changes the size and or the shape of a figure. So this laser was making the triangles larger. So it was changing the size. Oh, there it is. All right. Now, because it changes the size or the shape, that means that dilations are non-rigid. That's a very important distinction, that they're non-rigid. All right. I have an example of a dilation. This is a dilation. Let me add that. This is a dilation. And I'll explain how I know later. This is a dilation. Okay, so I have a rule, by the way, and I have 3 points, 0, 4, 2, 4, and 1, 2. I'm going to put these points through this rule, and we're going to see that when I plot the image points from the pre-image points, you're going to see that I get a shape that is a different size and a different shape. Okay, so this is going to do actually both. All right, so A, which is 0, 4, is going to map to 2 times 0, so that's still 0. Well, let me write this A prime. 2 times 0 is still 0. And then half of 4 is 2. So A prime goes to 0, 2. B, which is 2, 4, is going to map to B prime. 2 times 2 is going to get me to 4. And then half of 4 is going to get me to 2. All right, and C, which is 1, 2, is going to map to C prime, which is twice the x, which is 2. And half the y, which is now 1. So let me plot these points and draw our new shape. 0, 2 for A prime. 4, 2 for B prime. And 2, 1 for C prime. So that's A prime, B prime, and here's my C prime. So you can see that the size changed and the shape changed. So this is in fact a dilation, and I knew it was a dilation because we're multiplying. Multiplying implies a dilation, okay? With the exception of changing signs. Multiplying by a number other than -1 implies a dilation. Now, we've also heard the word dilation used when we talk about our pupils. The eyes are dilated. Their pupils are dilated, sorry. They're larger or smaller than before. So this is an example again. I wanted to show you that I could change the size and the shape of an object by putting it through a rule that involves multiplication. And again, any multiplication other than -1 implies dilation, okay? So I'm going to go ahead and check off our first goal. Remember, dilations change the size and the shape, and dilations are non-rigid. Let's move on to our second goal here. And our second goal is we're going to review the rules for rigid motions, which are translations, reflections, and rotations. And right now I have just the translations written where A is large, or where A and B are larger than 0, and the order pair XY maps to X plus A comma Y. So we slid A units to the right. Remember, translations are slides. Let me add that here. Our second translation is the point XY maps to X minus A comma Y, and so we're sliding A units to the left. Our third translation could be X comma Y maps to X comma Y plus B, so we're sliding B units up. I wouldn't say I slide B units to the up, but B units up. And our last one is the point XY maps to X comma Y minus B, and we're going to slide the figure B units down. So let me go ahead and erase everything. I'm going to come back, finish the second goal, and then we'll go ahead and jump into our last goal. So let me clean everything up, and I'll be back. I'm back. All right, let's continue with our second goal. I want to spend a little time on translations and just remind you how we can represent a translation. Remember, translations can be written 3 ways, and a translation is a slide. It can be written as a rule. An example would be XY maps to X plus A, comma, Y minus B as a vector. So I want to go in this direction, that far, that's the magnitude. Or in component form, which just means I write my direction right or left, and then my direction up or down with, I don't know what you call those symbols, but that symbol right here tells me component form. I do have an example of a mapping or a rule. So this is written as a rule. Let me write that out. So this is a rule. And this rule says that XY maps to X plus 2, comma, Y minus 3. So this means we slide 2 units to the right and 3 units down. And in vector form, this would look like this. Notice that I go over 2 units. Right? So 1, 2. And I also drop 3 units. So here's 1, 2, 3. So I'm saying go right 2, down 3, right 2, down 3. And in component form, it would look like this. So this is telling me to go right 2, down 3. And I just wanted to go over this to remind you that we can say the same translation in 3 different ways. So let me erase this and set up the last part of the second goal, talking about reflections and rotations. Let me clean this up and I'll be back. I'm back. We're going to continue with the second goal, which is reviewing the rules for rigid motions, which are translations, reflections, and rotations. Here I have our reflections, which are the flips, and it's over the x-axis. So xy goes to x minus y, so we're just changing the sign of y. If we reflect over the y-axis, xy becomes negative x comma y, and we change the sign of x. If I reflect over the diagonal line y equals x, xy maps to yx, so we just switch the order. And if I reflect over the line y equals negative x, xy maps to negative y comma negative x. We switch the order and change the signs of xy. So I included a translation of what's happening from the pre-image to the image, and hopefully that helps you understand this a little bit better as we move forward. Let's review the spins, and we spin about the origin. If I want to spin in a 90-degree or a negative 270-degree angle, xy maps to negative yx. We switch the order and change the sign of the y. If I want to rotate 180 degrees or negative 180 degrees, xy maps to negative x, negative y. So we just change the signs of the x and y. And if I want to rotate 270 degrees or negative 90 degrees, xy maps to y comma negative x. We switch the order and we change the sign of x. Now, just to review, rotating in the counterclockwise direction is a rotation in a positive direction. Rotating in the clockwise direction is a rotation in the negative direction. So make sure you have all of these rules somewhere that's easy for you to find, because it'll help you through this section and through the homework. There's a lot to memorize. And so if you just have it in front of you and you use it enough, you'll actually end up memorizing it. So make sure this is somewhere easy to find. I'm going to go ahead and erase all this, come back and start working on our third goal. I'll be back. I'm back. Let's go ahead and start our third goal today. Remember, our third goal is introductions to sequence of transformations, how to use the rules, and does order matter? All right, so a sequence of transformations means that we're applying two or more rigid and or non-rigid transformations to a geometric figure. So an example of a sequence of transformations means that I'm going to do two or more things to it. Here I have a reflection over the y-axis. I just memorized that from the rule. Here I have a dilation because I'm multiplying by a number other than -1. All right, so I have an example. I like to map my point A, which is 4, 6, using the previous example. And then I'd like you to try mapping -3, 10 using the previous example. And let's see if we get the same answer. And if we do, we're in a good spot. I'd also like to show you what's happening graphically with all of this, see how it's moving around. And I do need to talk about some notation. So like right here, I have 2 prime marks, which we call a double prime. And I hid my marker for myself really well. And so hopefully I have a marker that works good. All right, so here we go. A is 4, 6. So I'm going to start off with point A. And the mapping is telling me that I go from my original point and I now change the sign of the x because that's what the negative x means. And so now I get A prime is -4, 6. All right. And my next transformation is I'm going to double the value of the x and halve the value of the y. So -4 is going to now become, actually let me take a step back. A is now going to become A double prime. And I'm going to double that because that's what it's telling me to do. So I get an 8 now, or -8. And I have the y value. So now half of 6 is going to give me the 3. Double prime means that we've moved twice. Triple prime means that we move 3 times. Quadruple prime 4 times. I don't think we go above triple prime in this class. But double prime we move twice. So why don't you try this one? I hit pause. I can't hit pause. You hit pause, try to work this out, and then jump back in and see if you got it right. So hit pause. I'm back. All right, so we start with point B, which is -3, 10. And that maps to B prime by changing the sign of the x value. That's all we have to do. The y value stays the same, so my -3 becomes now a +3 and a +3, 10. Now I'm going to double the x value and halve the y value. So B double prime is going to be 6, 5. B double prime is 6, 5. So I know I moved it twice, I moved it once, and that's my pre-image. Okay. I don't know if you call this an image. I don't know the correct notation or the correct name for it. Pre-image, image. Who knows? I don't know. All right. So I'd like to graph these things and show you what's happening here. So I have the segment AB. So I start off with 4, 6 and -3, 10. So 4, 6. And -3, 10. And my A. And my B. And I'm going to connect you. I'm not very good at drawing straight lines. Okay, but now I'm going to go to my A prime, B prime, which I'm going to draw in purple. Now remember, this is a reflection over the x-axis, so I'm flipping over the x-axis, and I'm looking for my purple marker, and I can't find it because it's all the way over here. All right, so A prime is minus 4, 6. And B prime is 310. So you see it flipped over the y-axis. I think I said x-axis earlier. I meant to say y-axis. I apologize. And let me draw my now A double prime. So A double prime is a dilation. It's going to stretch or shrink. It's going to change the shape and or the size. And I did that in red. So minus 8, 3. Minus 8, 3. That's my A double prime. And 6, 5, that is my B double prime. 6, 5. Double prime. So you can see that the length actually horizontally doubled, while the height got cut in half. Right? So, not from there, from there to there. So hopefully this is making sense on how to use the rules. I'm going to erase all this, come back, and I'd like to discuss, does order matter? So let me clean this off, and I'll be back. I'm back for the last time, I promise. Let's go ahead and jump back into our third goal. And our third goal is, does the order for a sequence of transformations matter? An example is a reflection over the y-axis and a 90-degree rotation the same as a 90-degree rotation and a reflection over the y-axis. So this is actually a really good math question because it's going to force you to, figure out what we know. So how do we determine if they're the same or not? What do we know? The only thing we know are the rules, right? So I know that I know that a reflection over the y-axis, so a reflection over the y-axis, I know that my xy is going to change. That's a terrible arrow. My xy is going to change to negative x comma y. I know for my 90-degree rotation, I know that my xy is going to turn into negative yx. So what we can do is we can make a sequence of transformations out of these, right? So I can make the first sequence of transformations the following. xy is going to reflect over the y-axis, so xy turns into minus x comma y. And then I do a 90-degree rotation, so whatever I have here turns into minus y comma x. Right? A reflection and then a 90-degree rotation. And my other possible order for a sequence of transformations would be that xy now rotates to negative yx. And then whatever I have from here, I now do my reflection and I change the sign of the x and I get this. So what we're going to do is we're just going to pick a nice point that's easy to move around and switch the numbers around, I recommend using a point where the numbers are different. So for me, I would use something like A, where A is 2, 1. Let me make sure I'm still on the screen here. Okay, I am. I'm tired of having to redo these things over and over and over again today. I'd like to finish it on this cut. So I'm going to pick a point. The numbers are different. They're both positive, so it will be real easy to see what's happening. All right, so if I start off here with A, which is 2, 1, and I switch the sign of my x value, which is what this is telling me to do, I get A prime is minus 2, 1. Okay, and now I'm going to rotate 90 degrees, and so it's telling me to take whatever I have, switch the order, and change the sign of the y value. So that maps to A double prime, -1, -2. So if I was to draw a quick graph of this, I know that I start off about here, 2, 1, right? And when I reflect, I get to -2, 1. So that's reflecting over the x-axis. So there's my A prime. And then I rotate, so I'm going to go to the next quadrant in the counterclockwise direction. And that takes me to -1, 2. So there's my A double prime. I ended up in the third quadrant. All right, so let's do this sequence of transformations. Again, I start with A being at 2, 1. And that's going to map to A prime. And this is telling me to take whatever I have, switch the order, and change the sign of the y. So I go -1, 2. And then I'm going to map to a reflection, and it's telling me to take whatever my x value is and change the sign. So A double prime becomes 1, 2. All right, so these are different. So for this example, they are not the same. And let me just reinforce that with the graph. So here I started at 2, 1. I rotated to -1, 2. There's my A prime. And then I reflected back over the y-axis and I ended up here. I ended up way far away from this. Now, I would like to also make another observation. So an observation. This did not work for different transformations. But what about a rotation and a rotation? Right? What about a reflection and a reflection? What about a translation and a translation? I don't know. I don't know. I do not know the answer to this. What about, oh my gosh, what about? I am doing so bad grammatically. Oh, this is terrible. What about? I can walk and chew gum. What about two rotations, or reflections, or translations? Two of the same rigid motion. All right, I'm going to go ahead and end it here. Hopefully this is enough for you guys to do your homework out there. Again, I hope everyone's doing all right out there. Have a good day, everybody. I clapped in the wrong place. Let me try that again. Have a good day, everybody. Bye-bye.